All right, here is an example of a proof from section 2.6. This is number 11. 2.6 was all about the multiplication and division properties, so you know that that's going to probably show up in this problem. All right, so this is a proof. So I'm going to make my two columns. Because the given's already there, I'm not going to rewrite it all. I'm just going to say like quotations to represent all of this information right here. So what I am going to do is mark it in the picture, and that is SZ is congruent to ST, XY is congruent to VW, and then Y is the midpoint and V is the midpoint. Y is the midpoint of ZX and V is the midpoint of TW. So for this particular problem, you see these double words, midpoint, midpoint. So automatically I'm thinking about multiplication and division properties. Okay? So looking at this, I have little pieces, VW and YX congruent. And I kind of want to prove, I want to end up proving SX, the big parts, SX and SW are congruent. So let's see what to do. So I got these little parts congruent. I know that the little parts touch a midpoint. So you know you're probably going to think little parts, big parts. I can prove right now TW is congruent to ZX. All right. You want to pause right now and just try to determine why that's true, you could do that. But TW is going to be congruent to ZX by the multiplication property. So if little parts or small parts congruent, then like multiples are congruent. Okay? So that proves TW and ZX are congruent. So TW is congruent to ZX. I already know SZ and ST are congruent, so I'm just one short step away from proving what I want, and that is that SX is congruent to SW, because I now know that TW is congruent to ZX. I know this is just an addition property, so SX and SW are congruent because I'm just adding congruent segments here and here to the congruent segments here and here. So I get sums that are congruent. This is straight up addition property. So I hope that helps you with problem 11 from 2.6.